In this lecture, we're going to be working out a very interesting problem on matrix multiplication. Let's look at the problem statement. We have t times a column vector that produces another column vector, and then we have t times another column vector, and the multiplication of which produces another column vector. Now the question here is to find out what is t times a matrix. But the very first question you should be asking that what t is. Do we have enough information about t? Do we know what t is? Whether it's a matrix, is it a vector? What is it? Let's try to find that out first. Looking at this, we can see that t is getting multiplied with a vector that produces a vector. If you think about the matrix equation, a matrix times a vector that produces a vector. And also t is capitalized here. So if it was a vector, then t shouldn't have been capitalized. That could have been a smaller letter. But since t is a capital letter, we know that matrices are denoted by capital letters. So in that sense, we can say t is a matrix. T is not a vector for sure. T is going to be a matrix. But until we know what the order for that matrix is, we can't really make any progress in this problem. So let's try to find out what the order for t is. So in all of these places, t is same. So we can just focus on one of them to find out the order for t. And once we know the order, then it's going to be the same t everywhere else. So let's try to find out the order for t. So let's focus on this case. T is getting multiplied with a column vector which has order 2 by 1. So I'm going to write the order 2 by 1. So because it has 2 rows and 1 column. And that produces another column vector with 2 rows and 1 column. So the order for that would also be 2 by 1. Now we want to find out the order for t. So let me put a box over here times a box over here. So we'll find out the order for t. Now we know in the case of matrix multiplication, these two has to match. These two has to match. If they match, then only then we can perform this multiplication operation. If they do not match, they don't qualify for multiplication. Since we multiplied them and found out a vector, which means they qualified for multiplication, which means they agreed on this. This is the column of the first matrix, and this is the row of the second matrix. They have to be same. So this is 2, this has to be 2. Okay. Now we know that the resultant matrix, the order for a resultant matrix, can be found from here. So the column for the second matrix will be the column for the resultant matrix, and the row for the first matrix will be the row for the resultant matrix. So since we perform this multiplication successfully and the row for the resultant matrix is 2, from here we can infer that the row for the matrix T would be 2. So from here we can see that T is a 2 by 2 matrix. No confusion about that. Now we know that T is a 2 by 2 matrix, but we don't know the entries of T. So let's assume, let T be a 2 by 2 matrix or a square matrix with entries. We don't know what the entries are, so we're just going to assume A, B, C, D. T is a 2 by 2 matrix with entries this. Okay. Now we have this equation. Let's try to work on this equation first. So now we have T times a column vector with entries 4, -3, which is equal to another column vector with entries -3 and 4. This is the equation, and we now know what T is, at least for now. We can replace this matrix for T. So let's do that. In place of T, I'm going to write A, B, C, D with these entries. T is constructed, and then we have this column vector with entries 4, -3. that produces another column vector with entries -3 and 4. Okay. Now we learned in the previous section how to multiply a matrix with a vector. The very first thing we need to check quickly is whether the order for them agree in order to qualify for multiplication. This is a 2 by 2 matrix. This is a 2 by 1 matrix. So these two agree, which means we can multiply them. So now let's go ahead and try to multiply them. And we learned how to multiply them. The way we're going to multiply them is we're going to select the first row of the first matrix, and we're going to select the first column of the second matrix. For the first matrix, we always think about it in terms of row, and the second matrix, we're going to think column-wise. Now we pick the first element of the row that we have selected from the first matrix, and the first element of the column that we have selected from the second matrix. So let's select them, and then we're going to multiply them. So 4 times A gives you 4A. And then we're still on the same row that we have selected. The next entry, we select the next entry. We're still on the same column from the second matrix, and we select the next entry, which is at the bottom. So we're going to multiply these two now. So that gives you -3b, and we were supposed to add all of them up since we already have a negative sign, so the positive sign becomes negative. Now what we like to do is we're going to select the next row, and we're still on the same column. So the first entry of the second row is C, and the first entry of this column is 4, so we can write 4C. And then we're still on the same row that we have selected, and the next entry of that row is D, and the next entry of that column from the second matrix is -3, so we can write -3D, and we were supposed to add all of them up. We already have a negative sign, so the positive sign then becomes negative. So that's okay. So this is the way we can multiply. So I can write that to be equal to what we have on the right hand side, -3 and 4. Great. So from here, so we have this is equal to this entry, so I can write 4a minus 3b to be equal to -3, and this is equal to this, so I can write 4c minus 3d is equal to 4. Great. Now we're going to work on the second case, the second equation that we are given. So let's write this down. And the second equation that we have is t times the column vector with entries -3 and 1, which is equal to the column vector with entries 0 and 5. Now we're going to multiply them, and we assumed t to be equal to a matrix with entries A, B, C, D, and we have this column vector, so I can write it over here, which is equal to this column vector. I can write it over here. Okay, now we have to multiply them, and we already learned how to multiply them. So let's do that. We're going to select this row and this column, and then we're going to pick the first element from this row and this column, and then we can write -3a. We're still on the same row. We're going to select the second element, and then we're still in the same column. We're going to select the next element of that column, and then we multiply them. It becomes b, and then finally we're going to add all of them up. Now we go ahead and select the next row, and we are still on the same column. We don't have any other column, but each of the rows will hit each of the columns. That's the idea. So at first this row hits this column. This row also has to hit this column. Now we pick the first element from this selected row and first element of this selected column. Then I can write -3c, and then I select the next entry of the same row, and from here I select the next entry within the same column, and then we multiply them, it becomes D, and then we're going to add all of them up. Okay, so this is what we have now. And this is equal to what we have on the other side, which is a column vector with entries 0 and 5. Now, from here, we then have, so you can write, then we have this to be equal to this. So I can write negative 3a plus b equal to 0, and this to be equal to this. So I can write negative 3c plus d equal to 5. Now we worked on these two equations, and from both of them we found two equations from each of these, and we might be able to use them over here. Now the ultimate goal is to calculate this, so T multiplied with another matrix. So we're gonna work on this now. So we have T here, which is a 2 by 2 matrix, getting multiplied with another matrix with entries 4, negative 3, and 1. Okay, that's the matrix we're going to multiply with T. But what is T? Remember, we assumed T to be equal to A, B, C, D. And this matrix, we can write this over here with entries 4, negative 3, and 1. Now this looks like a matrix getting multiplied with another matrix. Now let's check their order. This is a 2 by 2 matrix. This is also a 2 by 2 matrix. And these two numbers, they totally match, which means we can perform the multiplication operation. Previously, we multiplied a matrix with a vector, but now both of these are square matrix. So what is the key difference between them? There should have some differences. Remember how we multiplied matrix in the previous case. When we're trying to choose the next element, this is roughly what we did. We move, for the first matrix, we move from left to right to choose the next element. And for the second matrix, we go from up to down. So this is the kind of transition we made for choosing the next elements. So this is the key. Now over here we have, in place of one column, like in the case of a vector, now we have two columns, which means we have to do second time this operation. This kind of, I'm just roughly sketching the idea. So this is the kind of operation we have to do for the second time. Let me show you what I mean by that. Let me actually do it. So we can select a row. So we're gonna select the first row and the first column from here, which is this first operation. Let's say first row, first column. I'm going to select the first entry of the first row and first entry of the first column that I've selected, and I'm going to multiply them. So this is going to be 4a. Now I'm going to select the second entry of the same row from the first matrix, and this was column wise, so I have to select the next entry of the same column that I've selected. Then it's going to be negative 3b, multiply them and add all of them up, so then it becomes negative 3b. So that gives me the first element of the first row of the new matrix. Now this is the first operation that I've done. This row hits this column. Now this row has to hit this column as well. Each of these rows will hit each of these columns. That's the key idea. Now this row will hit this column. Okay, so we select the first element. We select the first element of the selected row, and we select the first element of the selected column. This time we're completely going to forget about the previously selected column. We're ignoring the previously selected column, but previously selected row will still be active. So this row will hit this column only. First two elements, multiply them. We're going to write it on this side because this operation now will produce the second entry of the first row of this new matrix. If I set this parentheses over here, then this is the first element of the first row. Now, when the first row, we're still working on the first row will hit the second column. That will produce the second entry of the first row. Now, this is going to hit this. So then, this 2 multiplies and it gives you negative 3a. So we're going to get negative 3a. Now, the next entry within this column would be b. So I'm going to select b. And the next entry within this column would be 1. So I'm going to multiply both of them. So b times 1 gives you b, and I'm going to add all of them up. So it's going to be b plus b. Okay. Now we have to work on the second row in a similar fashion. So this is what we have done over here. First row hits the first column. That's the one. We're still on the first row. We're still on the same row, right? And that is hitting the second column. So this hits the second column, and these 2 entries I get. Now what we're going to do is we're gonna select the second row, and then this time it will select the first row again. Like I said, that each row will hit each of the columns of the second matrix. Each of the rows of the first matrix will hit each of the columns of the second matrix. That is the essence of it. So this time I've selected the second row of the first matrix, and now I completely forget about the first row of the first matrix. Now we are on this row. Now let's select the first entry of this row, and now currently we're on this column. Now let's select the first entry of this column. So we have, if you multiply these 2, then it's going to be 4 times c, so it's going to be 4c. I can write 4c, and then the next entry of the same row is d, and the next entry of the same column is negative 3. So we multiply these 2, and we're going to get negative 3d, since we add all of them up. So negative plus positive, that becomes negative, and it gives you negative 3d. So this is what I get by using this kind of operation. This is a rough sketch, so don't take it too formally, just for the sake of explanation and discussion. So this is the operation that I've done over here, right? So I get this element. Now I have to find out this entry of this new matrix, and the way to find it out is if this row hits this column, the second column. So now let's do that. So we still have this row selected, and we're going to change our selection for column. Now we are on this column. So now the first element of this selected row and the first entry of this selected column, we can select and multiply them. So that gives you negative 3 times c, so it's going to be negative 3c. And then we select the next entry by using this idea. So we go from left to right. The next entry is then going to be d, and then in this column the next entry is 1. So if we multiply them, it's going to give you d times 1 is d, so we're going to add all of them up, so that gives you plus d. Now this is what we get. First this operation, and then within the same row this operation to get this element and that element, and then you change the row, select another row, and you do the same operation. Each row will hit each of the columns of the second matrix, and you get all these entries of this new matrix. Okay, so I hope by now you have a clear idea about how to multiply matrices. It's a little bit tricky, but once you get used to that and solve a couple of problems, then you're going to be super comfortable with this style of multiplication of matrix. Now, so far this is what we have, but does that mean we already have an answer? No, because we don't know what these are. We don't know the values of these, but hey, we worked them out from these two given equations. Remember, we worked on this given equation, and we found that this is equal to this is equal to this, right? So we found two equations from each of these cases, another two equations from this case. So which means we have four equations, and probably we're going to find an answer out of that. So let's see what answer do we have by now. Okay, so let's work on this one. It's 4a minus 3b. So what is 4a minus 3b? What is the value of 4a minus 3b? Previously, we worked on 4a minus 3b to be equal to negative 3. So from here, I can write, in place of this, I can write negative 3. And then I have negative 3a plus b. What is negative 3a plus b? Negative 3a plus b. This is negative 3a plus b. So which is equal to 0. So in this place, I can write 0. Then I have 4c minus 3d. What is 4c minus 3d? That comes from here. 4c minus 3d, that's equal to 4. So in place of this, I can write 4. Then I have negative c plus d. What is negative c plus d? This is negative c plus d, and that gives you 5. So in place of this, I can write 5. And that's the answer to our question. This is what we wanted to calculate, right? And we found that this turns out to be this new matrix with entries negative 3, 0, 4, and 5. And this is exactly what we wanted to calculate. And we have figured it out. That's it. See you in the next lecture.